on a part number P199, small air screw from the 1930s aeroplane constructor set. Hi folks and welcome back. It's the 6th of the Space 2501 build, the ground base. Writing this, I'm yet to unpack this set from whichever box it's stored in, and there's that bit in me which has an unfounded fear that it's missing. It's not, I just still have boxes to deal with. But the resupply side of life is as much part of space as it is our day-to-day life, and maybe more so. Because you can't just pop out to the shop and get a bottle of milk. Logistics is a major part of any operation, but more so in space, because in space you also have the additional problem of weight to deal with. And this week I'm going to attempt to delve into some of that problem, as well as look at some of the insane claims that get made on missions that never seem to happen. So my first statement of weight is a problem to deal with. In a weightless environment, it has to surely be wrong. Well, space might be weightless, or more to the point it has less gravity to affect mass, but our planet has plenty of gravity to affect the mass of what we load aboard spacecraft. That will then need to break free of Earth's gravity field. So while mass never changes, the effect of gravity on the mass does. So weight as we know it is the physical effect of the mass of an object's interaction with the gravity field it's passing through. Here's a thought then. When the nurse or doctor is telling you to lose weight, tell them you need to be living on the moon because a gravity field of 1.6 newtons per kilogram will be a sixth of the weight you are on Earth. Mars will have you about 30% lighter at 3.7 newtons per kilogram, compared to Earth's 9.8 newtons per kilogram. The mass will remain the same, of course, because the mass is unchanged. I'm not sure how well that will go down with them, so let me know. 2024 is, according to NASA, the year that America puts a base on the moon. I'm going to guess that they are behind schedule, which given the complexity of the mission is no great surprise. The resupply of the base from Earth would be the greatest logistical problem that the mission would face. The first is getting there, but the second one is a monetary cost. To put 1 kilogram of cargo, any cargo, into low Earth orbit, known as LEO, has a hefty price tag attached. The figures go from anywhere from $10,000 up to $20,000. SpaceX is around $2,800. If any of you think that the retired space shuttle would be a better option, then here is food for thought. Its price tag was around $55,000 per kilogram. From LEO, or LEO, the cargo could be placed aboard a cargo rocket and then fired off towards the base. I guess that's a relatively easy one. For humans, there are two things we need: oxygen and water. And both are cargoes that would need to be carried or replicated in space. Water is the easiest to do, but maybe not the nicest thing to talk about. Pound for pound, water is one of the most expensive things to ship. So aboard the International Space Station, the ISS, it's captured from the environment, from humidity as we breathe out, the sweat on our skin, the brown water from showers, and yes, you also have urine. The complete recycling of water, all water, is a must, because at the average consumption rate of 146 litres per person per day, the operation is unaffordable. Oxygen is another vital one, but this is a bit more difficult to do. In most cases, a spaceship will only carry what's needed, plus a margin of error for emergencies. But aboard the ISS, the task is completed by oxygen generators, with a backup of pressurised oxygen tanks and solid fuel oxygen generators called an SFOG. The three systems provide a vital belt and braces backup for the station. For while lack of water is a problem, a lack of oxygen is a bigger one. Some of this can be helped by the science experiments that would be carried out on a ground base, that of growing plants. Plants will help to scrub the atmosphere clean of CO2 and help to replace it with oxygen. While they use water to grow, they also return a certain amount of that back in the form of humidity. And even if that will not replace all the oxygen that is consumed, it will help to alleviate some of the stress on the generators, making their life easier. Food is, of course, another big problem. Some of that will have to be provided in the form of dried food. That will need to be rehydrated. Again, you see the need for effective water recycling. But if you're growing food, then you get to add some fresh food into your diet. The storyline from the 2015 film The Martian has the main character farming in his own poop. And yes, that is as disgusting as it sounds. It's actually one of the best methods. And it's what we do now. The need to add chemicals to soil or moon dust to allow plants to grow would be essential, as right now it will have little to no chemicals or nutrients in the ground. It's also recycling of waste matter. Being self-sustainable allows the ground base to operate and reduces the resupply runs from Earth. And I commented on the cost and the value per kilogram and how SpaceX is so much cheaper. And this is probably the future, as I see it. Private-run companies employed to resupply instead of space agencies like NASA having to do the heavy lifting. The other really big logistical problem is how does the base get there in the first place? This model only has booster rockets, and I would guess at the minimum to at least land. But maybe the ability to travel through space as well. I am speculating that NASA's moon base, Artemis, will be built on the moon. And that enters one of the biggest problems that they've encountered on the surface of our nearest neighbour: dust. Or more to the point, very sharp, jagged dust that gets into everything and will wear holes in spacesuits. It might seem very funny that dust, such a small thing, can cause so much damage, even risk the very lives of the astronauts wearing the suits. But any dust disturbed on the moon can be a killer. This is down to the atmosphere of the planet, or more to the point, the lack of it. And that's the difference on Earth, and to some lesser extent Mars. What our atmosphere does is to wear away at the sharp and jagged particles of dust. In the case of the moon, it's rock, ejected it would seem from Earth sometime in its distant past, possibly when Theia collided with the then proto-Earth nearly 5 billion years ago. But these particles of rock have never been worn down by the action of wind and rain, by the passing of seasons. Nature has not had a chance to work her wonderful magic on the moon. It is dead. But there is one part of the ground base that I've left out. The part that can turn this into a horror story: the crew. Stuck with each other, unable to escape, might well be more than some people could cope with. It's easy to say you have a job to do, get on with it, but day after day, dealing with a personality that is annoying or narcissistical could well drive you to murder. And people change, sometimes all too quickly. Of all the models that I've built so far, this one maybe could have been the most playable in my youth. The stories that could have been told around it, the heroes or villains, depending on which TV show I've been watching at the time, either rescuing or conquering a new world. But to be honest, this Meccano set arrived too late for my imagination to take interest. Lego had arrived, and the few Lego space sets that I had got played with much more. The biggest hobby for me by now was that of Airfix kits, and my first ventures into wargaming, and the beginning of a lifelong love of knowledge and history. Coming back to this as an adult, I find this multi-kit lacking in many ways. Maybe it just doesn't like my rocket, so to speak. And the logistics of moving my clutter into space would just not work. But at least my Meccano is just about all unboxed. The What's in the Bench is about to restart. Will have restarted by the time this airs. The next stage is to find a job in the so-called real world and begin to rebuild again.